In the previous tutorial, we visualized our data, which gave us more insight into our data sets. Now, in this tutorial, what we're going to be doing is we're going to be performing some machine learning regression analysis. So we're going to be training a linear regression model, and then with this model, we're going to be able to predict our population based on land area. This is going to help us to understand how much population growth we can expect as the city expands with respect to its borders. So to do this, we're going to be checking some key metrics as well. We're going to be checking for our model accuracy, and then we're going to be looking at our trend. When we visualize our data, that is our regression analysis, we're going to check our trend. So we're going to be doing a visualization as well. We're going to be visualizing for population versus land area. So from that, we're going to check our trend, and then our trend is going to show the general growth for Ghanaian cities. When we get into that, we're going to use our plot to explain what our trend will look like based on what we've achieved. And then we're going to be predicting population based on some kind of arbitrary land area. So for instance, if we had a new urban development, say a satellite city, and then this satellite city was created with a land area of, let's say, 1,500 kilometers squared, we should be able to make a machine learning prediction. And then from that, our model can estimate what size that city would eventually be, in terms of the population size it can support. So our machine learning prediction should be able to estimate the population based on that prediction. So before we get into the code and such, this is where we were in our previous tutorial. I have my kernel running here. So if you type Jupyter Notebook and you press enter, this should run, and then it's going to serve as some kind of background server for this localhost environment. So this is what we did in our previous tutorial. We saved this figure, and this was the figure here. I've explained that in the previous video, so you can check that out. So here we're going to start with our machine learning algorithm, and then to do that, or before we do that, maybe I should give a little background into what linear regression is. So a linear regression is a foundational supervised learning algorithm that is used to model relationship between an input, which is the independent variable, and an output, which is the dependent variable. So at the core of linear regression is the model. So you can see model cost function optimization. So the model is some kind of hypothesis, and this hypothesis assumes that our output y can be predicted from a linear combination of input features x. So if we had a single input, we could have a simple linear regression with this equation. So this equation is y hat equals to theta 0 plus theta 1 multiplied by x. And this equation is similar to the equation of a straight line graph. So for y hat, so that's going to be the predicted value, which is the output. And then for theta 0, that is going to be our bias or intercept on the y-axis. So The intercept is going to be the value of y when x is 0. And then for theta 1, that is going to be our slope or weight. And then that slope or weight is going to measure the rate at which the predicted value changes for 1 unit of x. And then x is going to be our feature or input value. So like we said, this equation is similar to the equation of the straight line graph. So you can think of this, or you might think of this as y equals to mx plus c. So for those of you who are familiar with that, so m is the gradient, m is the gradient, c is the intercept, and then we can get for values of y based on the range of values of x. I'm talking about high school or algebra now. So you can see the graph here. It's a straight line graph. So this measures the trend. This what is it called? This straight line. It measures the trend. Okay. We're not going to be getting into cost function optimization, the metrics, mean square error, gradient descent, and the likes. When we get into machine learning properly, we're going to be diving into all of these concepts. So this is just the background into the algorithm that we're going to be using to make our prediction and our machine learning regression analysis in this video. So let's get back to Jupyter Notebook. So to begin, we're going to import, what is it called? We're going to from sklearn. From sklearn, we're going to be importing, what is it called now? The name's linear model. And then from here, we're going to import linear regression, like so. And then we're going to be making some plot as well. So let's do from matplotlib.pyplot. That's the namespace. No, I'm just trying to, this should be imports matplotlib.pyplot as PLT. So I think that should do for the matplotlib. And then we should load our data, but I think we've loaded it in the previous workflow. But let's see whether we still have access to it so that we don't run into any kind of error. So if I do data.info, okay, so we still have our data. Good. So I'm going to go back here, and then I'm going to type what we have here. So let me run this so that nothing happens. Okay, so let's go back here. Good. Okay. So here we can have, let's write a code for visualizing our data. So I'm just going to put visualization. So that's going to be, we're going to be visualizing population versus land area. So let's write a code for that. Then we're going to plt.figure. Let's set our figure size equals the weight is 10 and then the height is going to be 6, like so. Okay, let me check something. Okay, all right, I think we're good. So plt.figure, that's for that. And then we can do no, actually I'm jumping the gun. We can't visualize our data if we have not loaded our data, so sorry for that. First thing we're going to do is we're going to prepare our data. So let's prepare our data. So here I'm going to do machine learning. So this is predicting population based on land area. If I could type land area, and then here we're going to prepare our data, and then here we're going to have x equals data, and then I'm going to pass what is it called, a nested a nested array. So this is going to be, how x is our independent variable, so this is going to, I'm going to copy that here. Okay, I'm going to copy this and I'm going to paste it here. So this is going to be a nested array dot values. So that's that. And then we're going to do for y, it's going to be data. Y is the dependent variable, so you can just do population dot values. So this is the name of the column in our data set. Okay, now we can call our linear regression constructor regression like so. Oh, that should be model equals to linear regression, and then we can fit our model, the model dot fit, and then we pass x and y like so. So that's that. Come on now. Okay, now we can predict for existing data. So let me just do predictions for existing data. Then if we had an hypothetical future city, let's say over 1,500 kilometer squared. Okay, so how do we handle that with our machine learning prediction? So we can do data, and then for our data, so this is going to be a new column. Let's call that predicted population. If I could type, equals model dot predict. So we're going to pass x here. So that's our input. All right, so we're going to set a variable for our hypothetical area, and this is going to be a numpy array. So it's going to be np dot array. So because this expects a 2D numpy array, so we're going to pass a nested array here. So we said we're using 1,500 kilometers squared. So pay attention to this. It has to be nested like this. Okay. So for that we can do future prediction, and then here we can call model dot predict, and then here we can pass hypothetical area, hypothetical area like so. Okay, now the next thing we want to do is we want to visualize our regression line. So we say visualization of a regression line. Okay, and then here we're going to plot, so we can do plc.figure. Okay, plc.figure, this goes up a bit. Okay, plc.figure, and then we have to set a figure size here, figure size. Let's set that to 10 width, 6 height, and then for more control, let's do plc.scatter. So this is more low level compared to seaborne or scatter plot that we used in the previous tutorial. So where we pass x, y, and then let's have some styling, color, set that to blue, and then let's have label. It's going to be what's called actual data, and then alpha, which is the transparency of our plots, 0.5, so more like opacity if you like. And then let's do plot, and then in here we can pass x, and then we want to use our new column, which is predicted population. Let me see, I hope I got the spelling right. Population, and then let's have some styling. We can do color is equals to red, and then line weight, let's set that to 2, and then for the label, let's call that regression line label. Let's call that set that to regression line. Okay, so that's trend. What am I doing? Trend. Okay, like so. Now we can set our title, so we can do title, and then let's call that machine learning regression. Okay, machine learning regression, and then let's call predicting population from land area. Predicting population from land area, like so. And then for x label, x label, we're going to call that land area in kilometers squared. Land area in kilometers squared. And then for y label, y label, we're going to call that a population, and then we want to use legend, and then we want to save save figure, and then let's name it regression analysis.png. regression analysis.png, like so. And then we're going to close for memory management. Okay, and then let's print regression score before we run this cell. Let's print regression score. So here I'm going to do regression score. So this is going to be print. Let's have f string, and then here we can do regression score, which is r raised to power 2. So that's going to be, we're going to call model dot score, and then we're going to pass x and y here, x, y, and then we want 4 floating points, so dot 4f, like so. Okay, and then we want to print our predicted value, so that's going to be f string again, so it's going to be prediction for hypothetical 1,500 kilometer squared city. So that we're going to fetch that as an array as well. So we want an integer value. So we're gonna have this. What is it? Future prediction. This future prediction. So we're gonna call it as an array. Even though it's going to return just a single value, you have to call it as an array. 0, like so. I think I'm done with this. Okay. Now, before I run this cell, let me just check my syntax to be sure I didn't blunder that in the course of typing. Now I'm going to push this code into GitHub later on. So if you want, you can play with it. Let's see. Okay. I'm just going to run it. If I run into any issue at all, then I'll come back to it. So I'm going to run. Okay, so no issue. It says regression score 0.9108. So like this is when you look at what is it called? You look at this regression score, you realize it's very high score, which indicated that 91% of the variation in population can be explained simply by the land area. Now, when you look at what is it called? The prediction, it says 8,412,511. Okay, so so for that neuroband development satellite city that we talked about, which is our hypothetical city, where we apportioned 1,500 kilometers squared, you realize that our model prediction, it estimates that the city size would eventually support a population of this approximately 8,412,511. Okay, and then for our visualization, let's go back here. We save it as regression analysis.png. Let's see what we have here. Do we have it here? I don't think I have it here. Okay, is there regression analysis.png? So I'm just gonna click. Okay, now we have our visualization. Now this red line is the trend, see, and then this is our actual data. You see what we what is it called? You see what we're getting here in this what is it called? In our plot. So this is our trend, and these are actual data. Now you realize there are some cities that are above this trend, and there are cities that are below this trend. So when you look at it, this illustrates what is it called? Urban hierarchy in Ghana. So our data is from Ghana. So this what is it called? This trend, the red line, we said it shows the general growth path for Ghanaian cities. I don't think I've mentioned that, but anyway, this red line is the trend. What it does is it shows the general growth path for Ghanaian cities. So this city is above here. I think this is a Kumasi. This one is Kumasi, yeah, with respect to the population and the land area here. So the cities above this trend, what they are doing is they're overperforming in terms of population relative to their size. Whereas beneath this trend, you have Accra. So this is Accra up here. There's another city, there are other cities down here. So these cities are below the trend. What they're doing is they have more land area relative to their current population density. So which means eventually these cities down here, they are underperforming relative to their land area. So they can still take more population. These ones are overperforming. So just like the cities above here, they're like overpopulated, so to speak. That's what the data says anyway. So uh, guys, I hope you learned a thing or two in this tutorial. I'm going to stop here. I think this tutorial has gotten long enough. So I'm going to push this to GitHub so you can play with it if you like. So I'm going to see you in the next video.